Good morning, and first of all, let me thank the organizers for the invitation to this interesting meeting, and especially to my friend Pier Giuseppe Moroni for the recommendation. I think as one of the more famous British comedy show exports would have said, and now for something completely different. I'm a scientist, but I am a scientist that appreciates the importance of economics and of policy, and I have found the discussions in the last 24 hours or thereabouts very interesting. But I'm going to try and introduce a little science without getting too technical. So I apologize if some of you find this like maybe going back to school days. I promise I will not give you a chemistry lesson. But what I do want to do is try to introduce some really fundamental issues with regards to resource implications for sustainability. Because to me, as a scientist, when people talk about sustainability, I'm thinking in terms of everything that we use today in modern society, and, can we continue to use those articles, those items in the future? And as you can see, I have many pictures here. I could have had many other pictures as well. Only this morning I was reading about the fact that in Africa, where they are processing a lot of our electronic waste, they are now beginning to see some business opportunities. So that's kind of interesting because we have a lot of electronic items that we consume in the West, and of course the number of those items is increasing as the BRICS, we heard reference to earlier, as those countries increase their usage of those items as well. That's very interesting, but of course it ends up as a dangerous waste stream, which has been traditionally exported into places which are less able to manage those waste streams. There are some serious environmental concerns in all of these items. So for every item, there is a chemical story. There is a resource story. There is a resource or series of resources that are consumed to manufacture the items. The items are then used by us, by the world, and then we discard those items, normally into landfill sites. The majority of our waste still goes into landfill sites, which to me is criminal. It's actually a terrible waste of resource, and it's also an environmental burden. Now, the complexity of those items becomes greater and greater. We expect things to be more clever, to be more sophisticated, to be cheaper, but also to give us greater effects. So the mobile phone, the new Apple mobile phone, contains approximately 55 different elements. 10 years ago, a mobile phone contained about 20 elements. So we have made all of these articles more and more complicated. Now, the consequence of that is that we are putting more and more pressure onto the limited resources that we have available to manufacture those articles. So I'm going to talk a little bit about carbon resource to begin with, because that's fundamental to everything that we wear, we sit on, we use as fuels, and many of the items described here. The carbon resource that we have today comes from the petroleum refinery. This is something which we have created in the last century, and we have turned into an extremely efficient organism and also one of global value. Over 90% of the chemicals that we use today come from petroleum. That's the way it is. This is a very successful industry which has actually managed to balance energy and chemicals. About 10% of oil goes to making chemicals, but 50% of the value of oil is chemicals, something many people forget. We talk a lot about fuel, but sometimes I think we forget about chemicals. But everything I described before relies on oil. And that is a dangerous place to be when we know that oil is getting more and more difficult. Every new discovery is more and more environmentally challenging, is more economically demanding. And this will get worse. And of course, we all realize that it cannot last forever. This has to be the century of change. The latest data from the IPCC says that we need to stop using fossil reserves in this century. Otherwise, we will destroy the environment. And of course, fundamentally, we don't have that quantity of reserve available to carry on using. So, oil is a big problem, and most people recognize that. We need to find alternatives, and I will briefly suggest the kind of alternatives we can consider in Europe, for example, which is, I think, the focus of this meeting. But we are not simply consuming oil, carbon, in a way that's not sustainable. As I suggested before with the example of the mobile phone and many, many other items, we are actually consuming many other elements at a rate which is not sustainable. Now, here's the technical bit, and I'm not sure how many of you will recognize a periodic table. If you don't, it's not important. You can just focus on the things that are in red, because the ones that are in red, those are elements which are running out very, very quickly. Based on known reserves and our current rate of consumption, there are less than 50 years left of those elements in red. Those elements include tin, germanium, antimony, cadmium, silver, gold. These are elements that, for example, are essential to the electronics industry. Without those elements, there will be no electronics industry. Without those elements, there will be no automobile catalysis. Without those elements, there will be no pharmaceutical industry because they use them for catalysis. We just do not realize how embedded these elements are in the industries that we have today. Without them, there will be no society. And yet, we are only now beginning to realize that this is a problem. Indium, for example, one element that not many people have heard about, but indium is in every mobile phone. We now believe there are less than 10 years' resources of indium left. What will we do in the future? It's a very similar situation to petroleum. People say, we will discover new resources. In actual fact, we are struggling to find new resources. And every time we find one, the environmental burden and the economic costs go up and up and up all the time, the same as with oil. We cannot continue like this, taking things out of the ground, processing them, turning them into articles, and then throwing them away into landfill sites. That is crazy, and it's not sustainable. From a European perspective, the situation is even worse, because the elements that are remaining are not in Europe. We have very limited natural resources of those elements in Europe. We have some silver, we have some copper, we have some tin, we have some things, but most of the elements there are not in Europe. They are in places like Siberia, Africa, China, Latin America, and some in the Northern Americas as well. But we don't have them in Europe. So we are therefore going to be more and more reliant for our industries on elements that are going to become more and more scarce and potentially, of course, subject to more and more economically controlled and even politically controlled issues. Why do we have the problem? It's interesting because it's not as though those elements have disappeared. The atmosphere controls. The Earth is a limited ecosphere. Very little escapes from the Earth, maybe helium, which people do, of course, also identify as a problem element. But the majority of the elements I talked about before, like indium, like gold, and all these other ones, they stay in the Earth. We don't lose them. We simply transfer them from the original ore into a landfill site. That's the normal route for these elements. They end up in waste. And, of course, if you broaden the consideration to carbon, you can see all the different types of waste which actually we are now facing. Food waste, forestry waste, municipal waste, electronic waste. We see those as problems because they are environmentally blight on the economy, on the environment. Absolutely, they are dangerous to the environment. But I also see them as a terrible waste of resource, which ultimately, of course, will be our fate because we cannot, as I say, continue. So, to me, you put the two problems together, the waste problem and the resource problem, and you have a potential solution. And it's what a lot of people now refer to as a circular economy. We must get out of the mindset of assuming that once we are finished with an article, we can simply throw it away and not worry about the consequences. That cannot continue. Instead, we need to treat everything with respect. We need to understand those resources are limited and they are precious. So when we are finished with a certain article, we need to think about the resources in that article and find a way to get them back again. This is the only possible sustainable future. Now, at the moment, we are not doing this. This is just another quick look at the periodic table again. And here now we can see again a lot of elements in red. Those elements we currently recycle less than 1%. In fact, there are a very small number of elements in the middle, in blue, where we recycle more than 50%. The majority of elements we do not recycle. And of course, if we don't recycle, we can't get them back. If we can't get them back, they will run out, and with all the consequences I described before. So, as I said, we have to think differently. Now, it's interesting, but it's like, so if we have transferred a lot of the resource into what we now call waste, where is the waste? And I talked about landfill sites, which of course is very significant. But let's think about more broadly about where waste is. So landfill sites are an interesting opportunity. We do have technologies available to recover metals, for example, from landfill sites. Plants have a natural capacity for metals. It's extraordinary. I'm not a plant scientist. I don't fully understand this. but plants are capable of taking up high concentrations of metals into their root system. Now, we can take this technology, which is proven, we can apply it to landfill sites, and we can develop methods to capture some of those precious metal resources back again. I'm not saying this will solve all of our problems, but it just is an indication that there are technologies available today that can be used to help us move in the right direction to maintain our resources. Now, that's about metals, which, of course, are fundamentally important to our economy. But as is carbon, even more important. Carbon is something which really is intrinsic to us. We are carbon-based. Nature is carbon-based. Petroleum is carbon-based. And we have built a society which is very much focused on organic carbon, the exploitation of organic carbon. We eat organic carbon, we drive our cars fueled by organic carbon, we wear clothes using organic carbon manufacturing methods, etc., etc. So we have to think about the future supply of carbon. And as I said before, as we all realize, or we all say we realize, petroleum is not a sustainable future. We cannot wait for nature to spend hundreds of millions of years turning biomass into hydrocarbons to then allow the chemical industry to turn those hydrocarbons back into articles that we want for today's society. Of course, that is not sustainable. We will use probably around 100, 200 million years worth of resource in about 100 years. That's how totally unsustainable our practices are. But it's not the end. We can look around and be more clever about where we source our organic carbon. Because it's there, it's just in a form that we have not been used to using. Organic carbon is not simply in the form of petroleum or natural gas. It's actually present in the form of biomass, in the form of trees and grasses and plants, and also food waste. Food waste is something, this is the European Year Against Food Waste. And I've been very involved in writing policy papers and actually trying to develop something to go forward based around turning food waste into an opportunity. And Pier Giuseppe and myself chair and co-chair a cost action, a European cost action, which is all about food supply chain waste. It's all about saying this problem that we talk about is a very exciting opportunity. Now, part of that exercise, okay, there's lots of technology. Of course, there is lots of technology. But part of the exercise is the mapping. Where is the food supply chain waste? What is it? Where is it? And this is just some information about mapping. And if you just focus perhaps on some of the big numbers, you can look at any square as an example, if you like, and also maybe the numbers at the bottom. 1.3 billion metric tons of edible food waste has been estimated by the United Nations. Probably about 3 billion tons of inedible shells, peels, stones, straws, the things we do not eat, and are largely wasted. The potential, the organic chemical potential of those resources is fantastic. And in Europe, where, of course, we do grow things like cereal straws, we are also processing a lot of food. So actually, once again, it's there. The resource is there in Europe. It's just not in the form we have been used to using it in. In the same way, the metal resource is there, but it's now in landfill sites and not in ores that we're used to processing. So fantastic potential to go forward. And all this comes into what we now refer to as the biorefinery. And I travel the world extensively, and wherever I go, everybody is talking about the biorefinery. Because logically, this is the only sustainable future. The use of non-food, it must be non-food. We must learn from our mistakes with biofuels and not use food-quality crops. But if we can use non-food resources, of which, as I said, there are many, and convert those into chemicals that go into all of the articles that I showed you before, including biofuels, then I think we have a sustainable future. And as I've also indicated, we do have technologies already which are capable of doing this. The challenge is to persuade industry to move in that direction. Because, of course, the chemical industry, for example, has been very complacent based around a petroleum feedstock and also around conventional sources of metals, for example. It has to change. It has to change to go forward. I want to give you one example before I finish, because I feel as though the world needs a new OPEC. So one occasion when I was in Brazil, I came up with the idea, what we should have is an orange peel exploitation company, the new OPEC. And I chose orange as an example because there is more orange waste than maybe most people realize. In the gardens of this hotel, there are orange trees. In the south of Europe, oranges are very common. In North Africa, in South Africa, in China, in India, in North America, in South America, oranges are very common. And even when we don't grow oranges, like in my country, we process a lot of oranges. Oranges are a commodity, about 100 million tons a year, many of which are juiced. They're turned into orange juice that we all enjoy drinking. And then you have a waste, the peel. Most of that peel is wasted. We do not use it. Small amounts go into animal feed, but the majority is wasted. So this is just to finish with a kind of positive message, if you like, about the possibilities for taking one example, just one of many, many examples, and turning that into a future opportunity. So here we have, if you have interest in the chemicals, it gives you some indication there as to what's present. The peel contains limonene. Limonene is a common ingredient in many flavors and fragrances, many household products. You will have all smelt limonene when you peel an orange or when you're actually doing some washing in your house. It's also becoming a very interesting solvent for applications like cleaning as a replacement for hydrocarbon-based solvents. Flavonoids are health-giving products. They're used in many healthcare materials. Pectin is used for thickening. It's used in cosmetics. It's used for confectionaries. It has many, many applications. Sugars can be used to make other chemicals. So here we have a very interesting combination of products, interesting products with existing markets that can be taken from something that we currently throw away. I go to orange processing companies all the time, and often they are paying for somebody to come and take their orange peel away. And what they do, of course, is put it into a landfill site or even burn it. To me, that's a terrible waste. And to help us move towards a genuinely sustainable society for the future. Thank you very much.